Hello and welcome to Ashutosh Academy. Today we are going to deal with this new chapter in physics, that is heat and thermodynamics. Let's just starting this. The first thing that we have to deal in this chapter is the first law of thermodynamics. Okay, the first law of thermodynamics. Okay, should I write it or should I dictate it? Dynamics. Okay. Okay, what's then first law of thermodynamics? It's very simple. Suppose you have something like this, a system, okay, which is which is insulated from outside, and there's a piston which is also insulated from outside so that no heat can flow, and then you have this piston, movable piston, okay, this is movable piston, okay, and then you have your heating element here, okay. So and here any gas is present whose n moles of it is present, okay. So what happens here is when you start this electrical heating assembly, okay, then what happens, some kind of heat flows into the system. Let that heat be dq heat, okay. Then what can happen here, this heat is actually dissipated in the form of two things. First, either the piston will move up, okay, the first thing is either the piston will move up, and the second thing is that the temperature of the gas present here will increase, okay. Only these two things can happen here. So let that temperature change be the change in its energy. Let it be denoted by du, okay. So what should be our first law of thermodynamics then? It's very simple. You will have to remember this principle because it's conservation of energy principle, which is dq heat that you're providing is equal to du plus dw. This is the first law of thermodynamics, okay. dq is what? dq is heat energy given to system. Heat energy given to system, and du is change in internal energy of system. And what is dw? That is work done by system. I'll tell you the sign conventions later in this video only. Work done by system, okay. So this is our first law of thermodynamics, okay. Let's understand the sign convention for this first law of thermodynamics. It's very simple also. The sign convention goes, whenever, okay, let me write it down. dq can either be positive and it can be negative. If you are taking it as positive, that means heat is given to the system, okay. That means heat is given to the system. We can also say that heat is absorbed by the system, okay. When it is negative, that means heat is given by the system. Heat is given by the system, obviously to surroundings, okay. So this is the sign convention for dq. So what should be for d? Next thing is dw. Let's check out for dw. It can again be positive and negative. Both the cases are possible here also. If it is positive, that means work is done by system. Work is done by system, and this work is done by the system in the form of movement of the piston, okay. when the piston moves up or down, that means some kind of work is done by the gas. And when we say it is negative, that means work is done by surrounding on the system. Work done by surrounding on system. Okay, after this, what can be the other cases? There's one more thing for du. Okay, and for du it is again, for du can again be two things, either positive and negative. If it is positive, what is this d? Why am I writing d everywhere? Why dq is equals to du plus dw? D denotes differentiation, that is difference. Okay, difference. That means q final minus q initial, which is equals to u final minus u initial, which is also equals to work done final minus work done initial. This is how it goes. Whenever you are taking difference, we mean these things. Okay, if it is positive, that means internal energy of the gas increases. If positive, therefore internal energy of gas increases. And how will the internal energy of the gas increase? By temperature increasing. Okay, if it is negative, that means internal energy of gas has decreased. Okay, that means temperature has decreased. Okay, and if there is no change in volume, okay, we'll understand this, what is isochoric process and everything later on. For this, you'll have to just understand this first law of thermodynamics. Let's do some problems. Here I have the questions for you. You can pause the video and do these questions if you're interested in doing. So let's just start solving them. The first question says that when a system goes from A to B state, it is supplied with 400 joules of heat. Supplied, okay, and it does 100 joules of work. Okay, and now we have to find for the A part, for this transition, what is the system's change in internal energy. Okay, that's all. The system is going from A state to B state. Okay, this is the flow, and we know that heat is supplied to the system, that is positive then. Okay, and it says that it does 100 joules of work. Since the system is doing the work, that is again positive. So we apply the formula. We know that delta Q is delta U plus dW. So what will be the value of delta U? dQ is again 400. This is 400. This is 100. This will get this side. 400 minus 100 will be equal to delta U, that is 300, which is equals to change in internal energy of the system will be 300. Okay, I hope you've understood. Now let's do the B part. It says, if system moves from B to A position in the previous question, what is the change in internal energy this time? Okay, let's understand. Okay, this question first. See, the system is here A and B is here. The system is going from A to B in this direction, and if it were to move from B to A, then it will move from this direction. Okay, there's one point that you need to remember for solving this type of problem. It is internal energy of a system is a state function. Okay, internal energy is a state function. Okay, it is path independent. It's not gonna, this value internal energy of the system is not gonna change either if it is moving from A to B with any of the flow direction. Okay, but one more thing is clear from here, that moving from this side will be positive and coming from this side to this side will be negative, so that when both of them are added it gives sum as 0. That is, change in internal energy will be 0. Let's understand. The overall change in internal energy from moving from A to B and then coming back to A from B will be delta U from A to B plus delta U then B to A, and it's a cyclic process. Then obviously change in internal energy will be 0 because you're coming back to the same initial point, so it will be 0. And we got this value from the A part as 300 plus delta U BA will be 0. So it is clear that delta U BA path will be minus 300 joules, just opposite of the first one. Okay, and if you are not able to understand, then the best thing is delta U for a closed path is always 0. This is the note that you need to make here. Okay, it's a note for you that delta U for a closed path is always 0, and by using this note we can get this formula here and get this value. Okay, again, now you can pause the video and solve this second question. Okay, we will solve this solution of the second question in the next video.